right, so standard notation. Quick recap on this. Standard notation is sometimes also known as scientific notation. An example would be a number like 2.4 times 10 to the power of 2. This is standard notation, and this is ordinary form. If you write it as an ordinary number, you technically have to change this into 100 and then move the comma 2 spaces to the right, which is actually 240. Those two numbers are exactly the same. So you've got standard notation on the left-hand side, and you've got 240 on the right-hand side. And exactly the same, right? They're just written in different ways. We call it standard notation because the decimal is always right before the first number. It's not on the outside of the number. It's not next to the 4. It's not at the end. It's always in between the first digit and the second digit. All right, just over there you can see. That's the concept of standard notation, is to bring the decimal into that point here. So let's look at an example where I give you a number like 386, and I want to convert it from ordinary form into standard form. All right, standard notation or standard form. If I want to bring it into standard form, I got to move the decimal. Now remember, the decimal at the moment is hidden over here, right? If there's no decimal, we always remember there's a hidden decimal over there. So if I want to convert it into some 3.86, I want to get it to 3.86 and multiply it by 10 to the power of something, and I want to figure out what that something is, I have to move the decimal 2 spaces to the left. And so I end up with 3.86. But because I move the decimal to the left twice, this power becomes 2. So what does this mean? It means that if I've got 386 and it becomes 3.86 times 10 to the power of 2, the decimal moved 2 spaces to the left. And therefore, we also note that the power has increased. This power has increased by 2 as well. Power moved up by 2, or to the number 2. Let's look at what happens when we move the decimal to the right. Suppose I got the number 0.0386. And I want to convert this, so I move it across once, twice, it becomes 3.86. And because I'm moving it right, it becomes 10 to the power of negative 2 from this here. All right, 10 to the power of negative. So firstly, the decimal is moving 2 spaces to the right. And the power is moving 2 units into the negative, or down, right, into the negative. So let's get this straight. What we're noticing when it comes to standard notation, to summarize it, is that when the decimal goes to the right, the power goes into the negatives, or down. Actually, it doesn't have to go into the negatives. It just goes that many units down. So let's have an arrow down like that. If the decimal goes left, then we're saying the power will go up. Let's just recap that quickly. The first example over here, we got 386, right? So the hidden decimal is here. It moved 2 spaces to the left. And so the power moved up by 2 units. 2 there. So left implied up. Right? Left implied up with the power. So let's say I have a few questions over here and I want you to try, let's see, I want you to convert it from ordinary form into standard form. So ordinary form, let's say I got question 1, I got 3,876, convert it into standard form. Try. Grab a blank piece of paper in front of you now, and then try and convert 3876 into standard form. The next one, 0.00349. And the third one, I got 760.0734. Now I want you to convert that into standard form. I'll give you 3 minutes to try that. All right, so I'm gonna look at the first one here. Going from an ordinary number into standard form, the imaginary decimal is over here, and I'm gonna move it 1, 2, 3 spaces to the left. That becomes 3.876 times 10 to the power of 3, because I went left, right? So left implies power goes up. Right implies power goes down. All right. All right, so that's the first solution over there. I moved the decimal 3 spaces to the left, and the power went up by 3. The next one, I'm going to move the decimal 1, 2, 3 spaces. Remember, we want to get the decimal to go between the first visible digit and the second. In this case, it's going to be 3.49. Then we want to multiply it by 10 to the power of something, and that something is found by how many times we move the decimal. So 1, 2, 3 spaces to the right implies go down by 3, so negative 3 in this case. The next one, I've got to go left 1, 2 spaces to the left. It'll end up at 7.600734, and then multiplying it by 10 to the power of 1, 2 spaces to the left. So going left means that the power has to go up by 2. All right, and that would be in standard form for each of those.